Can I start it?
Okay. So here, this green, in the animation, if you see green filter, green square is sliding over the input. And some of the convolution goes into the features made.
Okay.
So, if you see from the beginning, here, once again, down arrow might be there is. Okay, yeah, just on the looking at that, I mean, I was out of touch with this one for a long time. So the area of the filter, the size of the filter is 3 into 3. 3 into 3 matrix is computed. 3 into 3 matrix is computed, and the result is 10 one by one, and it goes on like this. So it's a matrix calculation directly.
Okay.
So if you see at any point of time, 1 into 1, 1 into 1 minus 1 into 0. So if you see, if you bring 1 into 1 minus 1 into 0. So determinant, if you little bit remember the determinant, how we find it. So it will happen this into this minus this into this plus again this into this minus this into this. The sum of the result of this matrix will come here. Again, the result of this matrix will come here.
1 second, Jamie. So the value 4, how it is calculated, that value 4?
This 4, right?
Yeah.
Yeah, that is what I'm. So this first you see one matrix is there, 3 into 3 every time. Correct?
Yeah.
This 3 into 3 matrix is going on. So this 3 into 3 matrix at this point, let's say this one. So this is calculated. So what is the value of it's almost moving once again. Here, if it is showing here. So this is a convolution has been done of oh, this is not calculated yet. So it's so fast moving. So this is here if you see 1 into 1, this one, and this one is 1 into 0 when it comes, because these two are like this, 1 into 0, and this is this one. And this is 1 into 1 all there. That is because to go, this is 1 is to 1, and this is also 1 is to 1. So this will come down. So this is the finding the determination.
Okay.
So this is the bit pixel actually. Initially will be bit pixel. And then the 3 into 3, any matrix you can take, square matrix. And the matrix calculation will be done, and the resultant will be this one value. So this is one value, this is one value. Again, this is one value, this is the matrix will get reduced. From this matrix has been created to this one, 3 into 3. 1, 2, 3 times, 4, 5, 6 times, 7, 8, 9 times. Every time this green dotted matrix value has been calculated. And that is the what you see when a image has been put across. So it is converted into 1 and 0 bit only. And that is image matrix value is this one. So determinant, if you determine, if you don't even determine it. This one. This is the matrix. A into these things minus B into these things plus C into these things.
Okay.
A into, remove this row and column, this one. Minus B into, B is here, right? So it will come this one, D, F, I, H. Vertically and horizontally, the row and column will be removed.
Okay.
Minus, first is plus, second is minus, third is plus. Always happen like that. This is a, I mean, in the 12th standard actually it's there, so long back, right? So D, C into these things.
Right.
And this is how it is calculated from 1 and 0 and get this one result. For every one dotted matrix. So initial this 1 1 1 0 0, this is the picture map of the image, and that is reduced using finding the determination. Convolution perform on the input data with the use of a filter or kernel to then produce a feature map. This is the feature map.
Right.
Matrix multiplication is performed and sum of the results goes into the features map. So matrix multiplication. So this is what is the determination. So as I say, is a matrix multiplication and determination. 1 second, wait. This second, these values. Once again, I'll more clarify everything. Okay. So this one. The result of this one has been put into this value.
This one, okay.
Similarly, the next time it will come one
here.
Yeah, so it move one at a time, and that also we can adjust. So that is going to be the next value.
Okay.
And this is the matrix multiplication of it.
Okay.
So this is the result. And if I put so here, if you notice 1 into 1 minus 1 into 0, right? 1 second. If you see this one, last one, here it will come 1 into 0, this one. This is coming here. This is 0 into 1. So matrix dot products, matrix multiplication, you have to see the matrix multiplication. Okay, this is your understood, right? So matrix multiplication dot product.
Right.
At every location, matrix multiplication perform and sums the result put into. So we need to take a filter. We need to use the filter or kernel for the matrix multiplication. Right? So that is what it is taken. So it is not showing here. So the second terms is, so the dot convolution filter, here it is showing. So here it is. See, here it is. So convolution filter, as per this formula, so a filter will be taken.
Right.
And with that, the matrix multiplication will happen with that matrix. And then the result will go and put into the next layer.
Next layer.
So we perform numerous calculation on the input where each input uses a different filter. The result is different feature maps. At the end, we take this feature map and put them together as a final output.
Right.
Here it is, see, this is the previous layer and this is the last layer. When it takes on the bigger one map, so the calculation happens and produces small value.
Right.
And for that, one filter is used in middle. So just like neural network, we use activation function. So that is the different thing. The activation function and reliever, it will come after we cross into this stage, the last stage we got into.
Right.
Size of the feature map is always smaller than the input. So we have to do something to prevent our feature map from shrinking. So that means feature, the next layer is always reduced, right? From this map, this second will be reduced in dimension.
Right.
So for that, so it can be too small, the features. It can gradually, because we do it for many times, it can shrink very badly. And for that, they use a concept called padding to reduce it. A layer of 0 pixel value is added to surround the input values with 0 so that feature map do not shrink. Layer of 0 value pixel is added to surround. So surround means in addition to keeping the spatial size constant while performing convolution, padding or improve the feature performance and make the kernel strike. So what happens in the pixel value, zero value pixel is added to the surround the input.
Mm-hmm.
So if the value is very small, this one let's say, is saying that zero will be here, here, here like this.
Right.
So that the size will be same, although the value will be shrink.
Mm-hmm.
Padding also improves performance and makes sure the kernel and strike size will fit into the input. Kernel means filter.
Mm-hmm.
So if this one will shrink too badly, the next filter will not maybe not fit. So we want the features map to be do not shrink so much so that it can work with the next filter.
Okay.
After the convolution layer, so this is called convolution layer.
Mm-hmm.
This layer is convolution.
Right.
So after that, there is one layer that is called polling layer in between CNN. The function
Mm-hmm.
is function of polling is to continuously reduce the dimensionality to reduce the number of parameters and
Computation load.
shorter than training time and controls overfitting.
Mm-hmm.
So, so max polling with two into filters and stride two. So what is the max polling means? See, the most frequent type of polling. Polling is what we're talking about 1166. What is the maximum term? 6, right?
Mm-hmm.
So this is 6. In this square, the maximum value is 8, right?
Mm-hmm.
So the 8 is put here.
Okay.
Similarly, for it, come 3, and for it, 4.
Mm-hmm.
So this is the concept of max polling.
Mm-hmm.
So it takes the highest value from the square. So 2 into 2 filters we use to take the maximum value from the 2 into 2 matrix.
Mm-hmm.
So so we do what is like if you see this one,
Mm-hmm.
convolution and polling.
Mm-hmm.
So this thing is called convolution, where the dot product has been reduced, created to get the next features. The next features will be created using convolution.
Mm-hmm.
And activation function, okay, here also activation function is used. The output of the function will be passed through activation function. So this is the matrix, and if you put a filter of this, so it says that this is a input and this is a filter we take, and the product is giving you a value -3.
Mm-hmm.
So this is a convolution layer. And here, during this, we also use an activation function.
Mm-hmm.
To get into this destination, it uses a filter and do the dot matrix multiplication, and also use a activation function to get the desired output. So this is one thing, convolution, which created the next layer. And Then after that, with the parallelly, we do the second step is pulling. So pulling takes into a small features. So here is one more image is there showing. So let's imagine here. So this is input image, and in fast convolution, it creates a map like this. Out of this all big matrix, it creates with a filter, filter W1 it takes, and filter W, right? So this is the first filter W not it takes, and every time if you see it takes a result here. So when it works with this filter, it produces this result, and when it works with the next filter, it produces this result.
Okay.
So comparing with this. So I didn't polling is not visualized here, right? So filter is there. Yeah, polling is not showing here. So this is filtering is happened, and before output. Okay, this is convolution is already showing convolution and putting filter. This is the output, and after that, next is polling will happen. Polling will happen like this one. So again, the down steps will produce this one, and after that, a polling will use to work. This one will as it is. Once it is from the first convolutions, when it takes a filter and produces the dot matrix multiplication and get a small matrix, so then they apply a max pole, which gives you a reduced size. But then to stop for this one, prevent from shrinking, they use padding. So padding will happen at this one only. Give me 1 second. Hello? Yeah. Next one. Okay, you just come inside. There is a swastik interview written. Interior. This is from Indonesia. This is the second right. Second right is not Sony. Yeah, once again, yeah. Once again. Yeah, I mean, it actually somebody. So because I thought you are not pinging, so you are not there. So somebody asked in little bit early, and he's calling me, asking the office.
Okay.
So that is why. So after convolution, the max polling will work, and in between that, what I said, like this is not to overfeed. It uses over some polling layer. The function of the polling is to continuously reduce the density and reduce the parameters and computation of the network. But before that, padding is used. So padding is not showing how it is used. So it is just putting 0 in the pictures. So what happened after these things? Repeatedly, these two things happen. Then we flatten it. Whatever we have, we use two layer of this and we top it and flatten it. And after that, we use the neural network. It's a simple like a deep learning. Just I bring one person from outside. Just a minute. I stop the recording and continue it.
Okay.
Or keep it pause once. Amit, yeah.
Yes.
Yeah. So this is the theoretical background, and if you see this convolution, how it added.
So you started the recording, right?
Pardon? Yeah. I did. So this is the input image, let's say 500 into 512 pixels. So how the convolution should work? The input shape image should be given. This is how many images? 28 into 28 size of one image. So this is convolution. Convolution 2D of one second, like so once again, I'm just really out of touch with this. So this is one general image has been taken. 512 into 512 pixel with 3 channels. So I think this is equal to 28 into 28 size is 1 second. So number of filter, first parameter is number of filters. So here it is again 6 filters. And second is the kernel size. An integer or tuple list of 2 integers specifying the height and width of the 2D window. So for a 2D image, you should put 2. Sorry, I forgot actually. There is, it's a 2D image, right? We are working.
Right.
So that's why it is 2. Otherwise, you have to put 3.
3. Okay.
and number of convolution added 6 layer.
Mm-hmm.
If you see here,
So
filter.
where do you plot this? Okay.
Number of output filters.
Mm-hmm.
So number of output filters when it specifies,
Mm-hmm.
so number of how many times filters are how many convolution, right? So here it is one filter is produces, one destination will be produced.
Mm-hmm.
Again one filter is produced. So 6 filters are shown here. So 6 filters, 2-dimensional input and the input size, and activation function ReLU. And after convolution we have add a polling. So polling is this. You can check after this one polling,
Mm-hmm.
max polling. So this is where max polling, max poll to the
Right.
2-dimension.
Mm-hmm.
And this thing is done. This will create your input matrix into a small matrix, and with understanding of the image construction, it will interpret the image result.
Mm-hmm.
So basically, what we are doing, we reduce it map, reduce the pixels,
Right.
then add a flatten. Add flatten is this one.
Mm-hmm.
This one. We flat this. This is 2
Mm-hmm.
into 2, 3 dimension. If it is then 2 into 2 into 3 like that. Now it is 2 dimension. So it is flattened into 1 dimension.
Okay.
Like the neurons in deep neural networks. The input neuron.
Right. Mm-hmm.
These bit pixels will be converted into a single flat array with input dimension.
Right.
So we flatten it, then add dense with 10 neurons.
Mm-hmm.
So you flatten to convert 3D data to 1D.
Mm-hmm.
Sorry. Here it might be referring. This is a 3D image or what? So layer with 3 to 3 by 3 filters. So I'll let you know why it is putting 2 actually. It's just 2 for 2 dimension, 3 for 3 dimension,
Mm-hmm.
and integer to specifying the height and width of the 2D convolution. Okay, height and width it is specifying of it.
Mm-hmm.
So after it is flattening, a dense layer with 10 neurons. Dense layer with 10 neurons, if you compare with this image,
Mm-hmm.
so if you compare with the other neural network problem,
Mm-hmm.
use a dense right. So what is the
Mm-hmm.
so what is the last layer? It will specify you this one. The conversion it is of what type? So 10 if there is a type, so it is put it into 10.
Right.
So here if you see
Mm-hmm.
a dense layer with 10 neurons, the last one,
Mm-hmm.
and it uses softmax activation function for our last layer. So the last layer softmax is used.
So in the last layer, you specify that the image is truck, the image is car, the image is bus, whatever, right?
Yes, yes. So here it is yeah, this is the dance is 10 and softmax is activation function to find the result of
Mhm.
the 10. The last layer is always give you the what is the expected,
Mhm.
and this should be the output dimension.
Mhm. So like with this CNN, like you can train like one image at a time, or you can train like hundreds of images at a time.
Uh, every image will be trained differently, one by one. So
Okay.
you have to train
Okay, got it.
every image you can pass it through the layer
Okay.
because
So the first time.
every image will be like your data sets one data set, right?
Okay.
It
So
will
here is my question. So like first time you will take like a image of a car, you'll pass through the network.
mm,
Then you'll pass a truck. Then you'll pass a bus. You'll pass a maybe a motorbike, a
mm,
bicycle, something like this, right? So every time.
right. Yes.
And so like the image is, so the image can be like a let's assume a JPEG file, or it can be like a PNG file. It can be anything, or it has to be
It can be
specific one.
anything. It can be
It can.
any image, I mean standard PMP or JPEG or anything.
Okay, got it. And then like you train it, and then like you run it on your test data set, right? Which will be
Correct.
like a collection of images, and then
Yeah.
like based on what it has trained, it will predict like, okay, this is my car, something.
Yes,
Okay,
sir. Yes, that is what expected.
okay.
So here it is. The model has been created,
Mhm,
and model of summary giving you. I mean, what we are trying to do: convolution networks of this matrix,
mhm,
and use the activation function in that. Max polling we have
mhm,
used function. Flatten will create a shape of this much, and a
mhm,
dense layer expected output. In that activation function we have used this one to get the dense layer. This is activation is your convolution.
okay.
So that compile with sparse categorical entropy. This is same because of there are 10 classification.
Mhm,
And I mean 10 classification because we assume that we are going to supply 10 images.
that's okay.
Oh, okay. This is handwriting digits. So working on. So that's why.
Mhm,
So this is a handwriting digits. Here are data set import minis. So this is Kera has inbuilt this minis dataset is handwriting dataset. So X train and XTest takes from this one. Min is the load
mhm,
dataset, right? X train, X, Y train is created in one sentence like this. From
mhm,
Keras. So Keras inbuilt this one handwriting dataset.
mhm,
So train the model, iterating on the data in batches of 32 samples. So, okay, batch, we are running, here it is running in batch, 32 samples. So whenever batch is running means one will go at complete and the second will go.
mhm,
You cannot mix it. I mean, we're supplying in batch. So supplying in batch means, so one image will go, then the other will go, right? So train on 60,000 samples validated on 23 Okay, so I didn't run this one. So what it is doing is in batch. So this model is the same model we created earlier, right? So this is the model. So this is the model. We created it in convolution network.
Right.
And then this thing is dot feed only. So we get our data and we feed it, training it. And when we feed, then again we can get the data and do our test data and predict it. So this X test. So here it is already put at validation data is equal to X test Y test. So this will give you evaluation accuracy. Actual accuracy is this one, and validation is this one. Right? Both are similar, right?
Yeah.
So both actual and validation both works in similar. So there is and 1,000 samples, 10, sorry, how much? There are a lot of samples it runs. And one image, what I was saying is one image will go through the convolution layer one at a time. So, right, one cat image is there, we cannot mix cat and dog. So it will go and when you pass it, that bit pixel will take this and to understand that it will go through many iterations. Train on 60,000 samples. Validate on 10,000. So 60,000 samples are there, but 10,000 times we run all the samples.
Okay.
60,000 sample is there, then you have to definitely all the sample has to pass it.
Right.
But every sample takes every sample first time we get into one result. Again next time we'll get one result. Right? And it will go, the first one sample only will run through many times and get into one result. And the second one will start. So this way it will pass and get into the accuracy. Okay, so yeah, in some point I didn't check it document from 1 2 months. So suddenly I see something I missed it or what.
Yeah, it is something somewhat is like because like we have not been doing like consistent classes and also like this thing means I didn't understand that much clearly.
Yes, correct.
Uh, this and the LSTM part, the last class also like it was too much, especially like I had questions on that one too. So maybe like when I come back on Tuesday evening and when we do the classes from next Wednesday, means I'll prepare some questions on the previous topics also because like for the last 2 3 classes like the concepts are not very clear to me.
Yeah,
So
even yeah, it is the hardest things CNN and RNA
yeah. So
and
like
this is
if we can do some like a I mean I'll prepare some questions like the things which I don't understand and maybe like we'll keep like one class to go over those questions.
okay. So I will do one thing. The
Or maybe,
Wednesday
or
class.
maybe, or maybe like in every class we can put like say maybe 10 15 minutes to discuss those concerns because like I will very honest with you for the last few classes like I'm totally getting lost. So I means
But
once that
yeah, RNN implementation, did you got the implementation what they did? If you
the RNN was the last class, right? Or not? It was the previous one.
RNN theory was 3 class back, I think. After that 2 class we did practical.
Okay. Yeah, the last few classes like the RNN and all those things, the LSTM part means some things I understand, but some things I don't understand.
Okay, so we'll do one thing.
So
So as it is the last class CNN, so Wednesday, this class first will start and I'll put some questions and ask and also discuss like that way. So
Mm-hmm.
this area, and then we'll go to the RNN concepts.
Yeah.
So maybe 5 to 10 questions and then discuss and to make clear.
Yeah, because like if I understand these things, then it becomes easier for me to understand the algorithms and all those things.
Right.
So that way, like we can take this further. So like the CNN part, like do you have like something like a practice problem or something to do, or
Yes, yes, yes.
so maybe like you can send this link as well as the thing to practice. Means I won't be able to do it till Tuesday because I'm not home. I'll be going today evening. So
Okay.
if you can send it
And one
today.
thing, so CNN, try to put the concepts only. So we'll
Mm-hmm.
discuss on that. And CNN, yeah, this problem I will give you. This is the same thing. What you can do
Mm-hmm.
is directly
Okay.
and this link.
Yeah. Yes. Send me that. Means hopefully I will get the time to review it today in the afternoon. Otherwise, like when I come back on Tuesday, I'll review it and then we'll take it from Wednesday.
Okay. So
Okay.
yeah, this you can find it here only. I recently started putting the documents directly.
Okay.
Right.
Okay. That's fine.
So here only you can find it. So I'll put it. This is not completed actually. So I'll put it.
Okay.
So let me know if you can access it. So I didn't
Okay.
publicly publish it. So till now, once.
Mhm.
Uh, can you say you can see the contents there?
Yeah. 1 second.